Good morning. I welcome you to this session of internal combustion engine and gas turbine, and in continuation of my discussion on the combustion in SI and CI engines, today we will see the CI engine injection system. In fact, I have started my discussion on CI engine injection system, and we have discussed about one solid fuel injection system. We have discussed about the air fuel injection system, and as I said that solid injection system can be subclassified into three different categories, that is the common rail system, individual pump and nozzle, and unit injector. And yesterday we have discussed about the common rail system. So today we will see that the common rail system is having, of course, a few disadvantageous features. What are those? And if you need to go the modification of the common rail system, then in which way we can modify those modify this system essentially to improve the performance, or instead of using common rail system, what are the different other system, that is the unit individual pump and nozzle and unit injectors. So those part we will be discussing today. So we have started our discussion on common rail system, and if we can recall, in the last lecture we have discussed about the injection time, that if the crank traverses angle theta. So if we try to recall that and this is TDC, we have fuel nozzle, and nozzle is spraying fuel with a spray pattern into the engine cylinder, and this is bottom dead center, and the movement of the piston will be reciprocating one inside the cylinder, and if we connect that with the crank and connecting rod mechanism, we can have the rotary movement. So if we try to recall that this point we have identified by point B, and this is point A, and this angle is theta. So the point A is the point where injection starts, point B is the point where injection stops. So at point A injection starts, at point B injection stops. Now while moving from point A to point B, there is an angular displacement of the crank by an angle theta. So angular displacement of the crank by an angle theta. So now to traverse this distance, that is from A to B, the time required, that is the injection time. So that is what we have estimated in my last lecture. So this injection time if that is t, that is the time taken for this angular displacement by the crank, and that that time we have calculated theta by 6 n second. So this is what we have drive in the last lecture. So, now we are interested in the mass flow rate, that is very important. So, kg of fuel per cycle. So, that is very important, because when you are designing nozzle will be able to supply required amount of fuel which is demanded by the engine. Now, that means per cycle the amount of fuel that will be supplied by the nozzle, which is very important to optimize the engine performance. If the supplied fuel is less or higher than the design value, then combustion won't be the complete, and we need to compromise the power output from the engine. So, kg of fuel per cycle, that is very important to know whether the the fuel which is being supplied into the cylinder per cycle is adequate for the combustion or not. So, kg of fuel per cycle, that we can write, that is what in fact we have calculated in the last lecture. So, that is A1, that is area, into the velocity C1, that is what we have calculated in the last lecture, that is nothing but twice rho f into P2 minus P1 under root into theta by 6n. So, this is the expression for the kg of fuel per cycle. So, now if we do if we go ahead a few steps further, then we can write A1, this is twice P2 into rho f into 1 minus P1 by P2, this is also under root and to the power half into theta by 6n. So, now if we go to the next slide, that means we have calculated kg of fuel per cycle, that is A1 under root twice rho f P2 into 1 minus P1 by P2 power half into theta by 6n. So, now we can see there are three important, rather I can say three. So, kg of fuel per cycle is function of these three important terms, A1, 2 rho f P2 and 1 minus P1 by P2. See, P2 is the pressure, I can say that is the injection pressure, and P1 is the pressure, that is pressure inside the cylinder. So, this rho f, the fuel which is being supplied, so density of the fuel is constant. P2, if we design a particular nozzle, so I know the upstream of the nozzle what will be the pressure that will be developed by the pump itself. So, that is also fixed. So, this quantity A1, that is also fixed. So, this quantity is fixed. Instead, what we can see that 1 minus P1 by P2 now, if we try to draw the this part once again, we can see that this is P2 and pressure inside the cylinder is P1. Now, this P1 is always less than P critical. So, we can consider 1 minus P1 by P2 power half is constant. We can treat this term as constant. So, what we can write? We can write kg of fuel per cycle, that is nothing but I can take A1 into theta by 6n into CDF under root twice rho f P2, right. So, this is also constant which is called coefficient of discharge. P1 is always less than P critical. So, we can treat this term as constant, and that constant term we can take care by introducing one factor or one coefficient, that is coefficient of discharge. Now, P2 can also be assumed constant, right. As I said, P2 can also be assumed as constant. Now, A1 is also constant and rho f is also constant. Then we can write kg of fuel per cycle, which is equal to theta by 6 n into some constant k. So, this is constant, right. So, what we can see from this expression, that kg of fuel per cycle, this quantity depends upon theta and speed. Now, that is kg of fuel per cycle equal to constant theta by 6 n. If we go to the previous slide, fine. So, we have written correctly. Now, we do not have much control over theta. We do not have much control over theta, right. So, because since lifter is used for the displacement of the needle. Now, question is, in that case we can write kg of fuel per cycle is proportional to 1 upon n, where n is the speed of the engine. So, I just pointed out, rather I mentioned one important point in my last lecture, that the common rail system is very much important for the diesel engine or compression ignition engine, which is used to run alternator or generator. Now, to address this question today, we have derived this expression, that kg of fuel per cycle, which can be expressed, which is proportional to 1 upon rpm. So, speed of the engine. Now, this is very intuitive to say, if load increases, then of course speed will decrease. So, now I am writing, if load increases, n will decrease. So, that means we need to, if n decreases, what we can see from the expression. So, if we now focus on this expression, that kg of fuel per cycle is proportional to 1 upon n. Now, say let us say load is increased. So, the load which is demanded from the engine is increased. Now, what will happen? Speed will decrease. What we can see from this expression, when speed decreases, so fuel supply will increase. So, fuel supply will increase. Now, if fuel supply increases, then again there will be no problem. So, that means what I can say, load increases, speed will decrease, fuel supply will increase. This increased supply of fuel automatically will try to increase the load, increase the speed. So, these types of engines which are equipped with common rail system are called self governing engines. That means, we do not require any extra speed governing mechanism. Instead, what we can see, that the common rail system which is equipped with this kind of engine are having self governing mechanism. So, when load increases, speed will decrease. If speed decreases, we can see from the expression that the kg of fuel supplied to this cylinder per cycle will increase, which in turn will increase the speed again. So, these are called the self governing engines. Now, as I said, we know that when we run electrical generator, so we need to run electrical generator using a diesel engine. So, the engine which is used to run generator should have this kind of common rail system, so that Why it is important? Because generator is used to supply electricity. So, our I can, so I am writing that our home appliances are connected to generator, right. So, I can write that diesel engine which is used to run electrical generator to produce electricity, right. Now, this generator is used to supply electricity, and we can connect our home appliances to the generator. Now, most important is that N is equal to 120 F by P. So, this F is the frequency, P is the pole. So, what is important that we need to maintain constant frequency, because our home appliances, if the frequency changes, frequency oscillates, that is very detrimental to our home appliances. So, we need to maintain constant frequency. So, number of poles are fixed. So, what we need to ensure that the speed of the engine should be constant. Now, question is, in any case if we increase the load, then what will happen? Speed will decrease. If speed decreases, then frequency will be changed, and that is not desirable for this system. So, what we need to do? We need to maintain, we need to ensure that the engine should run at constant speed, and that is why this diesel engines which are connected to electrical generator should have common rail system for the fuel injection. So, this is what I mentioned in the last lecture. So, with this I will next. So, now we have discussed about common rail system, but at least we should know, we have seen this is a kind of advantageous feature of the common rail system, but at the same time we must know what are the different disadvantages associated with this injection system. So, I am writing disadvantages of the common rail system. So, I will write at least two, I can mention what are the defined disadvantages. So, first one is that the discharge coefficient is sensitive to the wear of the nozzle and to the deposit of solid matter on the needle. So, we can see that fuel will be discharged through the orifice. Now, there are two different problems associated with this system. First one, the deposition, that is what we have discussed, gum deposit. So, the solid matter, carbon particle may clog the orifice, that will be one problem. Not only that, the deposition of the solid matter on the needle itself will try to create the nozzle needle and also the total performance of the system. So, this is one of the important, rather I can say these two points we should keep in mind, that solid matter deposition on the needle as well as on the orifice will leads to reduction in the performance of the system, and we need to rather we can say the lifetime of the system will decrease. So, we need to go for very frequent servicing. So, that is not desirable for the injection system. So, this is the disadvantage. Now, next we try to see another important solid injection system, that is individual pump and nozzle. So, this is another important system which is used for the CI engine fuel injection system. So, I will try to discuss of course, but before that we need to see the schematic depiction of this system. From there, I mean the schematic depiction will help us to explain the mechanism of this system, and of course, then we will see what are the different again problems associated with this system. So, now I will try to draw the schematic depiction of this individual pump and nozzle system. So, So, this is the cylinder, this is needle, right. This is the fuel passage, fuel passage gallery, and this is leak return. We will explain, and this side is the injection side. And this side is the pump side. Right. This is cam, this is cylinder, this is fuel inlet port, I can say inlet port, this is plunger, and this is the delivery valve spring, and this is delivery valve, and this is cam follower, this is plunger, this is inlet port, this is called spill port, right, and this is delivery tube. Now, we have and see that schematic depiction. I will try to explain now. So, what we can see, this there are two different parts, one is the injection side, other is the pump side. So, the pump side which is responsible to pump the liquid, and the liquid which the fuel, liquid fuel which is pumped, that will be discharged through delivery tube to the fuel, to the needle. Now, needle shape is like this. So, as I said that the there will be I can say component. So, the force because of this high pressure fuel which is striking the needle will have two components, horizontal and the vertical. Horizontal components will balance each other, but the vertical components together will try to lift the needle upward, and the orifice through which a fuel will be discharged. So, since the needle is spring loaded, the normal tendency of the needle will be remain seated on the orifice. So, orifice will be blocked. When high pressure fuel is coming from the pump side through the delivery tube, the high pressure fuel is striking the needle, and from this Fibonacci diagram, what you can see, the say this is horizontal component, this is vertical component, this is vertical component, this is horizontal component. So, the force which is acting because of this high pressure fuel which is striking the needle face, because this is fuel. So, fuel will striking at both the walls of the needle. Now, the horizontal components will balance each other, but the vertical components will try to lift the needle by an amount which is required of the order of millimeter, and because of this movement, as the needle was originally seated on the orifice, So, this force, the vertical component, so this vertical component will try to lift the needle since it is spring loaded, and once the spring is lifted, once the needle is lifted by compressing the spring, the fuel will now discharge into the cylinder through the orifice. So, this is the concept. Now, we should know little bit more about the pumping system, and then what are the different, rather what is the most important advantage of this system. Now, see, if we now look at the pump side, what you can see that the plunger, of course, the movement of the plunger is responsible to supply fuel by lifting the delivery valve. So, if we now look at the delivery valve at the pump side, we can see the delivery valve is also spring loaded. So, the normal tendency of the delivery valve again will to remain block the pathway. So when plunger is lifting upward, the fuel will come from inlet port, the fuel will be now compressed by the movement of the plunger and pressure will build up, the pressure will be developed. So, the pressure will now try to lift the delivery valve and fuel will try to flow between the gap and that stop, these two are the delivery valve stop, and that high pressure fuel will now flow through the delivery tube and that will strike the needle. And also one important port is there, that is leak return port. So, the amount of fuel, because that is high pressure fuel, so the amount of fuel maybe all fuel should not be injected into the cylinder. So, if there is any residue, that will come out from the leak return and that will be taken back to the fuel pump or fuel reservoir. Now, so when the plunger is lifting upward, it will try to lift the delivery valve, and delivery valve will be lifted, high pressure fuel will now flow from cylinder through the delivery tube into the needle. So, when the force, the vertical components will now try to lift the needle and the force fuel will be injected into the cylinder, pressure will fall. Now, the fall in pressure will now again try to that pressure will be, will fall in the delivery tube as well. So, the fall in pressure will now try to allow the delivery valve to be seated on the stop. So, we can, that means by moving the plunger in this in the cylinder, we can now supply fuel per cycle as demanded by the engine. So, now I will write little bit about the plunger pump, which is important. We can see the spill port is there. So, the fuel which is compressed by the plunger, maybe all the fuels won't go through the delivery valve. So, there will be rather chances of leaking the fuel, and the fuel which is which is getting, I can say fuel is getting compressed. Because of this compression action, some portion of the fuel will leak and the leakage will now come out from the spill port, and it again the leakage fuel will be taken into the fuel reservoir. So, now I will write a few lines about the plunger pump, and then I will try to explain the problems associated with this system. So, the plunger pump operation. When the plunger is at bottom of its stroke, right, then next is both the intake and spill ports are uncovered. When plunger when plunger rises, these ports are sealed, right. the compressed fuel lifts the delivery valve and injection of fuel begins, right. Now, as the plunger continues to rise, the spill port is uncovered by the helical relief on the plunger. We will now write the helical relief that we will see in a detail, and at this point high pressure oil or fuel above the plunger escapes through the slot and through the spill port into the sump. That is very important. So, now I will try to draw the this. I have written two sentences that as the plunger continues to rise, the spill port is uncovered by the helical relief on the plunger. So, if we go back to this is the helical, these are the helical. So, we can when the plunger is rotating, we can rotate the plunger. So, now I will try to draw the schematic, and that will help you to understand what I have written over here. So, if I try to draw that, so that is the, say this is the intake port, and so this is the cylinder, and we have plunger which will have movement in this. So, the helical rack, so this is the helical rack. If I go, so these are the helical rack. Now, if we rotate, then so this is the spill port. So, and so what will happen, the when plunger continues to rise the spill port, then the spill port is uncovered and the helical relief on the plunger. So, this is the helical relief. So, by the helical relief, so this is the helical relief. Now, at this point high pressure oil above the plunger escapes through the helical relief through the slot and to, through the spill port into the sump. Now, so this is this schematic depiction, and there I can say operational principle, but again if I now go back to the schematic, then we can say that okay. So, the plunger is right connected with the cam follower and cam mechanism, So, the plunger will be lifted. When plunger is lifting, the fuel which is coming from inlet port will be compressed. The compressed fuel will now try to lift the delivery valve, and the delivery valve is spring loaded. So, the fuel will be discharged through the delivery valve, through the delivery tube, and into the cylinder, I mean injection site. So, the high pressure fuel will now strike the needle surface, and as we have discussed, the vertical components of that force will now try to lift the needle, and the amount of fuel, I mean which is required for the engine operation, will be discharged into the cylinder through the orifice. So, this is the case. Now, question is, there is an important problem associated with this system. What is that? And we have also discussed about the movement of the plunger, because when plunger is moving, maybe because we need to rotate the plunger using helical rack. So, the high pressure fuel, compressed fuel will now, that is what we have written, the spill port will be uncovered by the helical relief of the plunger, and at this point high pressure fuel or oil above the plunger escapes through the slot, that slot I have drawn, and above the plunger, and escape through the slot and through the spill port into the sump. Now, but when the high pressure fuel is coming from the delivery tube, because what I can say that overall travel or displacement of the plunger is controlled by the helix and spill port in proportion to the load. That means, whether we can, that is overall travel of the plunger. So, the plunger will move in the cylinder, but overall travel can be controlled by the helical rack that I have labeled over here, that will be controlled by this helical rack. Now, question is, depending upon the pressure that we need to develop, depending upon the fuel, of course depending upon the load, the amount of fuel you need to discharge into the cylinder, the movement of the plunger can be controlled, and that is done by the helical rack. So, now question is, the amount of fuel that also will be discharged into the cylinder, that also can be controlled by by suitably adjusting the plunger movement by the helical rack. So, that means maybe the plunger movement is the plunger movement will be restricted between these 2 points. So, that that is very important, that overall travel, overall displacement per stroke of the plunger is constant. So, if we need to supply required amount of fuel which is demanded by the engine depending upon the load, then how we can, because the pump is same. So, what we can see from the schematic, that the overall distance will be traveled by the plunger is constant. So, the pressure will be developed by the plunger will be constant, but what we can do, although the plunger is the movement of the plunger is compressing the fuel, but we can, by suitably adjusting, by controlling the movement of the plunger using helical rack, we can take some amount of compressed fuel back through the spill port into the sump, and in a way we can reduce the fuel pressure, and reduction in pressure will eventually control the amount of fuel will be discharged into the cylinder. Fine. Now, the problem associated with this system is that when in the delivery stroke, when fuel is coming out from the cylinder through the delivery tube into the cylinder, into the injection site cylinder. Now, when the fuel is striking the needle side, the vertical components will be responsible for lifting the needle, and by doing so we can discharge fuel into the cylinder. Now, question is, when the fuel is discharged into the cylinder, there will be reduction in pressure in the injection side. Because of this reduction in pressure, since the needle is spring loaded, it will have always tendency to block the orifice. So, a slight fall in pressure in the injection site, needle will try to be remain seated on the orifice, and as if there is a sudden I can say the sudden so pressure which is developed by the pump, and that pressure will be striking the needle. So, the amount of fuel that will be injected, and that there will be fall in pressure, and that fall in pressure will allow allow the needle to be remain seated on the orifice. So, we can have a sudden pressure surge, and that pressure surge, because at that time although we have pressure in the delivery tube, but the movement, rather the blocking of the fuel passage by the needle will allow a surge, and that surge will be transmitted through the delivery tube to the delivery valve. Since the delivery valve is already closed by the spring loaded, so again that surge will come back from the delivery valve to the delivery tube, and again the surge will strike the needle, and in doing so the needle may lift by an amount very small, and a small amount of fuel will be discharged, although it is not required. So I hope you have understood what I wanted to convey. That means what I would like to say, during the compression stroke, the fuel will come from pump side through the delivery tube, and it will strike the needle. So needle will be lifted, some part of the fuel will be discharged into the cylinder. Now as the needle is spring loaded, so when some part of the fuel will be discharged into the cylinder, there will be fall in pressure. So a reduction in pressure, that will also try to reduce the vertical force component, and then if that component the vertical force becomes lesser than the that spring loaded, that valve weight and the spring loaded, the force which is exerted by the spring, now the needle will be seated on the orifice. So there will be a sudden surge in pressure, that pressure will transmitted through the delivery pipe into the delivery valve, but delivery valve is already closed. So the pressure won't be able to allow fuel to go back into the pump side. So the delivery valve, since delivery valve is closed, the pressure again, that surge again will travel from delivery valve into the needle, and that returning surge will try to lift the needle by a very small amount, and some small, rather I can say small volume of fuel will be discharged into the cylinder, although that time it is not required. So this is what is known as after injection of the CI engine injection system. So this is very detrimental for the CI engine operation, and it will leads to reduction in the efficiency of the engine. So from this perspective, it is not advisable, rather if we try to use this individual pump and nozzle system, then we have to overcome this problem. So how can you overcome? That means the after injection, that is discharging of very small amount of fuel because of the returning surge from delivery valve into the needle, again we need to stop, and to remove this, to circumvent this problem associated with this system, we need to go for another system that is known as unit injector. So now I will try to draw the unit injector. So this is the problem associated with the individual pump and fuel system. Now question is, unit injector, I am drawing the schematic. Again the schematic depiction will help us to understand the mechanism, what is happening inside the system. Now we have cylinder, so this is the schematic of the unit injector. What we can see, So, if we now try to go back to the previous slide where we have discussed about the problems, rather problem associated with the individual pump and nozzle system. So, if we now try to think precisely, then we can say that the problems of this after injection, the problem of after injection, which is largely due to the delivery tube. So, the surge which is coming from the needle because of this sudden closing of the orifice by the needle, since it is spring loaded. Now, the surge which will travel from needle side to the delivery valve, again since the delivery valve is closed, the surge will travel back from the delivery valve into the needle, and that surge will try to lift the nozzle, lift the needle by an amount which is very small, and some portion of the fuel will discharge, although that was not required. Now, if we, that means the problem is, if we somehow can arrest the pressure surge, then the problem can be eliminated. So, instead of having the delivery tube, if we can remove the delivery tube from the system, and if we can place the pumping system on the top of the needle or the injection system, then we can remove the system. So, that means our objective is to remove the delivery valve, so that the travelling surge, the pressure surge can be arrested, and that is what is done in the unit injector. That means the pump system is placed on the top of the nozzle valve, so that the delivery valve can be, the problem associated with the travel of surge to the delivery valve can be eliminated. So, this is unit injector. Now, question is, so here I can write unit injector. So, the operation principle is same, same as the principle of individual pump and nozzle system, right. But the problem of after injection which is associated with the delivery tube is removed in the unit injector by placing the pump unit on the top of nozzle unit. So, we can eliminate this problem, but while we are doing this, we are also inviting another problem. So, maybe we can remove, but another problem of driving the widely separated pump is substituted. That means, maybe we can, not maybe, because we have seen the problem is largely because of the delivery tube, but that problem we can eliminate in this unit injector, but at the same time what we are doing, we need to know unit injector. So, we need a separate pump for separate unit. So, this is again another problem. So, system will be costly, because if we try to recall that So, this is individual pump and injection system, right. So, in this case one rack can do the job, but for the unit injector more racks are needed. So, what we can say that if we now try to compare the individual pump and injection system and the unit injector, the hydraulic difficulties associated with the individual pump and nozzle system can be eliminated by placing the pumping unit on the top of the nozzle or injector site, but at the same time another problem of driving the widely separated pump is substituted. Not only that, another important drawback of this system is that what we can see from this top left corner of this schematic, that only one rack can do the job for the individual pump and injection system. For the individual pump and injection system, on the other hand for the unit injector we need more racks. So, from the schematic which I have drawn at the top left corner, we can see that only one rack can do the job. So, this is rack and the movement is like this. So, rack can do the job, whereas for the unit injector we need more racks. So, this is only the difficulties associated with this unit injector system. So, what I can say to summarize today's discussion, that we have discussed about the common rail system, and as I pointed out, this common rail system is very important, rather very appropriate for the diesel engine which is used to run generator, that we have mathematically shown why it is important, why it is suitable for the diesel engine for which is used to run electrical generator. And then we have discussed about the disadvantageous feature of this common rail system, and having discussed the disadvantageous feature of the common rail system, we have seen the operational principle of the individual pump and injection system. We have discussed that using this system we can discharge fuel into the cylinder, but at the same time we are having another problem, that is hydraulic problem associated with this, and that problem leads to after injection, which is completely undesirable for the CI engine operation, that leads to reduction in the thermal efficiency. And to remove that, to eliminate this hydraulic problem associated with the individual pump injection system, another system is used for the CI engine, that is unit injector, where the problem which is we have identified the problem is coming from the delivery tube. So, if we somehow can replace the delivery tube, and then to do that the pumping system is placed on the top of the injection system, and that is why it is known as unit injector. But although using this unit injector we can eliminate the hydraulic problems, but at the same time we are inviting another problem of driving a widely separated pump, and also we need more racks to for the operation. So, with this I stop my discussion today, and we will continue our discussion in the next class. Thank you.